Yeah, welcome to this video. In this video we are going to discuss addition and subtraction of sets. In doing this, first there are prerequisites that we must to do, and the simple prerequisite that we have right now is to watch the previous videos on introduction and the reduction method on sets that we have learned so far. So in this video we need some tools, right? Yes, the basic tool that we need right now is our Casio calculator. So I know all SHS students, you must have one. If you don't have it, try to find one. And so this is my own. It's black, right? It may not look like your own. There are some regular one that we are using, but then, like, this is my scientific calculator. So yeah, we need it for this addition and subtraction. So in our previous video, we look at how to uh, reduce a number. So right now, I believe that if you are really watching these videos, you will understand why this and this are done on sets, and also you'll be able to you are ready to actually do addition and subtraction of sets if you have really watched those videos and understood. So yeah, in this video we are going to do addition or subtraction and subtraction of sets, as you said. um we every day the numbers I usually meet are 2 plus 3, 4 plus 5, 4 minus 7. But then these set numbers also numbers that how do we go about it, right? So let's look at an example. Let's say square root of 4 plus square root of 7. How do we add these sets together, or is it possible to add them? Is it not possible to do them? What is the limit, or what must we do and what must we not do? Yeah. So if you watch the reduction method, you realize that yeah, you have to find pair of numbers that at least give you and select the pair of numbers that will give you uh, one of the numbers being a perfect square. So like you can't be doing that every time, right? Today in this new world there is a tool, right? The calculator. That's how we say. That's what the tool you are going to use. So you don't need to basically do all that on your own all the time. We did that so that you understand what's going on, right? But once you have a lot to do, you have to show steps as well. But the calculator is the tool on your side to make sure that you are having the correct answer. So we are going to do all that in this video so that you know how to do all that. So for the addition of sales, right? Um, you basically have to add items, but you must show the steps as well. So some people go ahead and just put it in the calculator, and then whatever the answer they have it. But then if you do that, you might look marking your what's when they are marking your paper. So what you have to do, you have to follow steps and you have to be wise about it. And that's what we are coming to do. Yeah. So we are still going to do reduction, but then the reduction method is not going to be done by ourselves this time, but the calculator will do that for us. Yeah. So how do you go about that? Something like square root of 4 plus square root of 7, right? So first you go step by step. So square root of 4, right? So you go to the next line. Square root of 4. Put it in your calculator. What is square root of 4? Let me on my calculator. Yeah. So square root of 4. You enter that on your calculator. You press enter. You see your answer. And I got 2. So yeah, square root of 4. You got 2 plus square root of 7. Right? Square root of 7. Yeah. I have square root of still square root of 7. And we know what if you watch the previous video that 7 is a prime number. So there's no way to reduce them further. So if you cannot reduce them, they still remain under the square root, which is what we have. So this is what we have for this maybe this question. Now we are adding things, right? You might be having some question. So there's a number under the square root, and we are having 2 plus 7. Or if we are having, you might be thinking at the beginning, oh, why don't we do like square root of 7, right? That would be square root of 4 plus 7. So which is give you square root of 11. And square root of 11 is not, it's a prime number, so the answer will remain as such. If you do this to be wrong, basically you have to know that, have this in mind. Have this in mind that when you are doing addition or subtraction of sets, right? When you are doing addition or subtraction of sets, we don't touch, you don't touch what is under the square root. We don't touch it. After you simplified everything, we don't touch it. Like they don't add up. They themselves, they don't add up. They don't do any operation among themselves. Those under the square root, they don't do that. Right? Probably those that are outside the square roots attached to the numbers might be added or not. But those under the square root, we never touch them. So for example, in this case, you have square root of 4 plus square root of 7. It can be square root of 4 plus, because we are doing addition. The numbers under the square root, they don't interact. Let's have that in mind. When we are doing addition and subtraction, those under the square root, they don't interact among themselves. They don't interact among themselves. So we leave them as such, right? But if it were multiplication, which we will look further, we will see that they themselves can like interact. Once under the square can interact with another square root, like that. But if you are doing addition or subtraction, they don't interact. So you leave them as such. Because of addition, they don't come together. Now, so square root of 4 plus square root of 7. So we do square root of 4 on a calculator. We have to we put it here plus square root of 7 give us a, and yeah, this one has it's happened that the square root of 4 has lost its square root, right? So it's a perfect square, so you give us that plus square root of 7. Yeah, and that's the final answer because you cannot add them. Very good. That's how to go about this how do you call it, addition. Let's look at another example. I have square root of 5 plus square root of 2. Oh yeah, square root of 2. Yeah, so this is also addition, and in addition of sets, what did we say? Those under the square root, right? They don't interact. They don't do any, you can't add them. They don't interact among themselves. Those under the square root, they don't interact. So what do I mean by that? You cannot do this. You cannot do square root of 7, so it's going to be 5 plus 2 because you are putting them together. It does not happen. Addition of sets, those guys under the square root, they never interact. That's one thing. So this is a wrong thing way to pass. And what you actually do is that you put it in your calculator, right? If you put it in your calculator, you see have for root 5, you see have the square root of 5. For square root of 2, yeah, you see have the same square root of 2. Yeah, that's, you give it the same thing. Why? If you watch the previous video, you see that square root of 5 is a prime number, 2 is a prime number, so they come as such. You cannot further reduce them. That's why it seems like you have the same answers. Are we good? So the same thing applies to subtraction. If you are like if you are doing subtraction, if you are removing, like root 5 minus root 2, you cannot interact. There's those under the square root cannot interact among themselves. For addition and subtraction, they don't interact. That's fine. Now let's look at more examples. What if there is something in front of these square roots? What if there is something in front of these square roots? How are we going to do those guys that are outside? But we have agreed that those under the square root, right, they don't interact among themselves. Now let's look at cases where we have something in front of the square root, like 2 root 2, 3 root 2, and those stuff. Let's see how we can add them together. So I have my board clean. Let's see. So let me an example like 5 root 2 plus 3 root 2. Okay, so before that, let's look at this. 5 root 2 plus 3 root 3. I'm going to use this example to show you something. Right? We know that those under the square root, they don't interact among themselves. Okay, so this is the thing. The condition for those outside, like 3 root 2, and then for those outside, they are square roots, right? For them to add up, before you can add them or do interactions among them, those outside the square roots, for you to add them or for you to make sure that the interaction between them, there's one thing that you might see. You must make sure that their square roots are the same. So these guys, this is e square root, this one is also square root, and these square roots are the same. So if these square roots of these numbers, right, are the same, what do? Then those outside the square roots can interact. They can do the addition. They are the one that take part in the addition. So basically, if you are doing addition of sets or subtraction of sets, it's those that are outside their square roots that do the actual addition. But then before that addition can occur, even among them, you have to make sure that those under the square roots are the same before you can interact. They can interact among themselves. So how do you do that? So here you have root 2 and root 2. They are the same, right? It means that if they are the same, then we can these 2 and these can interact because their square roots are the same. So you just say 5 plus 3. 5 plus 3 is going to give us 8. And then you just bring back one of those roots that are the same. So this is the answer for this. This is the answer for this. So yeah, this addition was possible. We know that those under the square roots, they never interact, so we are not adding those inside. But then for addition, we focus on those that are outside. Now for those that are outside the square root, before they can add up, before you can add them up, you need to make sure that their square roots or those that are at their back are the same. You must make sure that those that are at their back, which is the square roots, are the same. So if they are the same, then that's it. You can just do the addition among those, only those outside, right? And replace only the square roots ones, yeah, which is 8 with 2. That's what we have finally. Let's look at this second example. So in this second example, yeah, we have roots. We know that this and this, they don't interact among them. They don't interact. The roots don't interact because of addition or subtraction. So when we are doing that, now we have to focus on those outside. And the one outside here is this guy. The one outside here is this guy. Okay, we are doing 5. We have 5 here and then 3 here. Okay, 5 and 3. We say we do addition for those outside. But before you can, those outside can interact for addition. What did we say? Their square roots must be the same. In this case, square root of 2 and square root of 3, their roots are the same. They are different. Square root of 2 and square root of 3 are different. So it's not possible to add those guys. It's not possible to add those guys, like those outside. Right? Those outside can only be added if their square roots are the same. So in this case, the answer, because it cannot be added, you can't do anything about it again. So the answer is still the same. Right? Yeah. This is the answer. So basically, that's how this addition or subtraction of sets works. So I haven't done any subtraction, right? Let me just do one. Negative 5 square root of 2 plus 3 root 2. Yeah, so here what we are seeing is that, okay, the roots are the same for these two guys. So since they are the same, what happened? Okay, since their roots are the same, then their outside can be interacted. They can interact among themselves. So over here, what do we have? We have minus 5. Here we have 3. Now look at this. If what is outside, there's a negative sign in front of it, like if you have 3 root 2, right, and you have negative 3 root 2, basically this one there is positive inside. So if it is positive in front of what number is outside, we don't actually worry about the sign. But if it is a negative sign that is in front of it, we carry it along. That's so what's in front of it is negative 3, not just 3. So yeah, so when you come back to this, negative 5 and 3. So if you put negative 5 and 3 together, it's like 3 minus 5. You are going to get negative 2. Negative 2. So the interaction of those outside give us negative 2. And then because the roots are the same, we just repeat it once. Yeah, that's it. That's how we do the subtraction sets. Now, the next one, we are going to look into more examples, right? There are more complicated examples than this. Let's see how we can handle them, and so the calculator will help us quickly. So yeah, they will give you they will not give you simply like 5 root 2 that you can easily see them, but there will be stuff, like really serious stuff that are coming up. Before we do that, let me tell you this. If you have square root of 17, right, there's always a number out here, but it doesn't show. That number is 1. 1 is always outside. 1 is always outside if you just have it like that. But if there's something from like 3 root 7, then you are fine. Are you good? So now it's the simplification, right? So you have something like let me give an example. Let's say we have 2 square root of what should I use? Let me use 8. Yeah, 2 square root of 8. So yeah, there's already 2, and then you know that this thing, right, this number will undergo reduction, but then you don't have to worry much. So you have 2 square root of 7. Let's put it in your calculator, right? At this point, you are going to use calculator. So 2 square root of 8. So I have 4. So the calculator gave us 4 square root of 2. But how is that possible? Right? If you watch the previous video, you know that this guy is not a prime number and it's not a perfect square, so we need to reduce it. When you reduce it, we are going to have 4 times 2 will give us 8. So there is one perfect square number. So if there is one perfect square number, it means that the square root of 8, right, is equal to square root of 4 times square root of 2. So square root of 4 we said is 2, and square root of 2 is 2, so it's 2 root 2. So this is only the root 8, right? Only the square root of 8. Remember, we also said that 2 root 8 is the same as 2 times square root of 8. But our new square root of 8 is now this guy. So we can rewrite, because of that, we can rewrite it like this. Can rewrite like this. So 2 times 2 square root of 2. So if you multiply those outside among themselves, we are going to have what? 4 square root of 2. That's why the calculator gave us that answer. So yeah, that's why it gave us that. But we are not really going to do this on our own right now because our two. But it's good that we understand why the calculator gave us such an answer. That's how to go about it. So that's what the calculator. So easily the calculator will easily give us the expressions. Let me give more examples for addition and subtraction. Then we just use calculator and quickly get it. So you don't have to put everything in your calculator, and if not, you lose mark when they are marking your papers. So what you have to do is that you have to be smart about using these tools. And so right now we are ready for the various ways of handling this stuff. Let me so there I'm having some examples here. So 4 root 3 plus root 3. So basically 4 root 3 plus, if you do this, this one is already a prime number. It doesn't undergo reduction. But then it's possible to add these two because what? Yeah, there's always 1 in front of you if there's nothing written. So 1 root 3, but they just say root 3. So if there's something in front of you, what do we say? If before you can do addition, right? Before you can do addition of the outside one, we said their roots might be the same, and the roots are the same. So 4 plus 1. 4 plus 1 will give us 5. So it's 5 root 3. So because the numbers are already reduced, right? All you have to do is just put it in the calculator. No one will ask you how did you get that answer, do you want to see, but you just put it like 4 square root of 3, then plus square root of 3. Yeah, the answer is 5 root 3. So yeah, that's how to go about it. Then let's look at further examples. So they gave us an example like there's another example from Aquila. I'm using Aquila. I guess you're also using that. So 3 plus 3 square root of 200 plus 2 over 3 square root of 162. You don't have to go and put everything in calculator and do that. No, this is what you have to do. So the next line, so put them under. So 3 square root of 8. What do we have? We have 6 root 2. We have 6 square root of 2. That's how we go for the first one. Plus 3 square root of 200. 3 square root of 200. Yeah, that's 30 root 2. Plus now 2 over 3. 2 over 3 square root of 162. 62. What do we have? We also have 6 root 2. 6 root 2. Wow. So this is what the calculator gave us for each of them. So this should be your next step, right? So when you are writing at paper, this should be your next step because they mark steps stepwise. So yeah. Now after that, what do? We know that because these ones are their roots are the same. You see that the root 2 is here, root 2 is here, root 2 is here. They are all the same. So if the roots are the same, we can the outside are qualified to be added together. So meaning that we can add 6 plus 30 plus 6, and root 2 is here. So what do we have? So 36, I think 42, right? So 42 root 2. So this is our final answer. This is our final answer. Let's solve the last one. The last one with the steps. So when you are doing this addition, again, you have to know how to use your calculator, right? And we understood we did that in the previous video, and we did that at the beginning of this video, why the calculator is given. So it's good to know why these are being given, and it's also good to balance it with how to use your calculator and not lose marks. Yeah. So let's see. So square root of 50, right? That's another example I have, plus square root of 32 minus square root of 162. So what I have here is, so square root of 50. Quickly, I'm going to put in my calculator. I have 5 root 2. 5 square root of 2 plus square root of 32. So I have 4 root 2 minus square root of 162. So square root of 162, we had 9 root 2. So what do I have? Because the roots are the same, root is the same, the root is the same, the root is the same. I have 5 plus 4 minus 9. The outside are qualified to be added together. So what do I have? It's going to be like 9 minus 9 root 2. It's going to be 0 root 2. 0 times any number is 0. So the answer for this one is 0. That's the answer for this particular one. Now let's look at other examples where maybe we not always have the roots being the same. We not have the roots always being the same. They are not the same. For example, let's say at the end of the day, we have, after you simplify, put your calculator, you have 2 root 3 minus 4 root 2 plus, let's say 3 root 5. Something like this. So if you have something like this, you see that once you do addition, there's addition and subtractions over here. But then if you look at the roots, right? The roots, we agree that the roots, they don't add up among themselves. They don't do interact with among themselves. So what you have to do is that you have to check if they are all the same. Oh, okay, this is not the same as anyone. So it's not the same as anyone. So yeah, we keep it like that. Root 2 is also not the same as anyone. And then root 5 2 is not anywhere else. So the answer remains the same. This is the same as how it is, because you can't add them. There's nothing you can do, because you have to follow the rules. Before you can add them, make sure the rules are the same. Once you have the same thing, you have 2 root 3 minus 4 root 3 plus 3 root 5. So what you see that in this case, you see that the root 3, right? The root 3 is here, root 3 is here. So this and this are qualified. They have made their outside qualified to be added, to interact. So it means that for this particular one, I'm talking about these two alone. You have 2 minus 4, which can interact, and there is root 3 there. This guy cannot interact with them because it is having a different root. So at the end of the day, we have this one be negative 2 root 2 plus 3 root 5. Yeah, so this will be the final answer for this. And you can't do any further because the roots are not the same. The roots are not the same, so the outside cannot interact. That's how it should. That's how it works. So yeah, that's how to be smart about how to do the addition and subtraction. So addition and subtraction happens when it's happening, we know that those under the square root themselves are not handled, like they don't interact among themselves. So if there are numbers that are need to be reduced, undergo reduction, we show you in the previous video how to know that this number will undergo reduction. So watch that video and understand. So if they undergo reduction, right, put them in a calculator. But if you have any question, you're not sure about if it will reduce or not, put each of them in a calculator, like how we did it in this case. Yes, I'm talking about this case, how we handle it in this case. Yeah, then we got here, right? So this one, this is its answer, this one, this is its answer, this one, this is its answer. Yeah, before we now, once they are now reduced, the calculator has reduced it for us. Now we check if the roots are the same. Those that have their roots are being the same, their outside can be interacted. If there's nothing outside that particular root, we have to know that there's always one in front of it. That's how to go about it. So yeah, we have to make sure that we know that those under the square root, they don't interact. And also we also believe that since they don't interact, those are outside, those that are outside of them, before they can interact, right? Also you have to make sure that they have the same roots. So if they have the same number under their square roots, then they can be interacted. Like so, or if you have something like 2 plus root 2, 2 plus root 2, if you have just 2 here like this, right? The guy under the square root of 2, if he's not with this, 2 plus root 1 root 2, because root 1 is always 1, square root of 1 is 1. We are talking about positive square roots, remember. Yeah, so 2 here, so the root 1 and root 2 are not the same. Here there's 1 in front. Root 1 and root 2 are not the same. That's why we cannot add 2 and 3. That's why you see them like this, simply like this, because we have 2 root 1, but we can't add. Root 1 and root 2 are not the same, so you cannot go ahead with them. That's why numbers like the 2 plus root 2, 2 plus whatever, they are maintained like this, because for addition to happen, they should have the same roots, and the roots themselves, those numbers under the square root, they don't interact. Yeah, this is how to go about the addition and subtraction. Solve more questions, and then and then be smart about using your calculator. Don't just run putting everything inside. You might lose marks. You might show steps like how we showed it in this video. Right? If you have any question, you can ask in the comment section. I hope that you solve more questions. And now that if you are solving it, you are not solving it just for solving, but you understand why this is doing it and why your calculator is giving you this and what to do at each step. So you understand the reduction method and why, when, and how the reduction method like is needed. Yeah. Thank you very much. In the next video, we'll look at how to do multiplications of sets, and then in this multiplication, let's see how it also and go under them. Right. See you in the next video. Please like and put down your comments so that we can reach out to you if any help is needed. Thank you very much, and then remember to subscribe. See you in the next video.